Okay guys, let us begin our discussion over the JEE advanced pattern exercises for sequences and series. First question is, if log 2, log of 2 to the power x minus 1 and log of 2 to the power x plus 3 are in AP, then what is the value of x? The very fact that these three terms are in AP means that twice of log of 2 to the power x minus 1 is equal to log 2 plus log of 2x plus 3. Right, so from here you get log of 2 to the power x minus 1 whole square equals log of 2 into 2 to the power x plus 3. You know log to the base e is a 1 function, so this implies 2 to the power x minus 1 whole square equals 2 into 2 to the power x plus 3. Which means 2 to the power x whole square, which is 2 to the power 2x plus 1 minus 2 into 2 to the power x equals 2 into 2 to the power x plus 6. So what are you left with is 2 to the power 2x minus 2 into 2 to the power x minus 2 into 2 to the power x, which is minus 4 into 2 to the power x plus 1 minus 6, which is minus 5. Okay, so from here, when you basically break the middle term, you get 2 to the power x minus 5 into 2 to the power x plus 1 equals 0. Now, I know that this can never be possible, that this is equal to 0. Why? Because 2 to the power x is never negative. So, if this is equal to 0, you basically get, what do you get? 2 to the power x equals minus 1, which is wrong. And therefore, for this expression to be 0, 2 to the power x will have to be equal to 5, or x will be log 5 to the base 2. And therefore, the value of x is log 5 to the base 2 for these three terms to be in arithmetic progression. Next question says what? It says that a, b, c are in AP and a square, b square, c square are in HP. If a, b, c follow what? So, A, B, C are in AP means that twice of B equals A plus C, and A square, B square, C square are in HP means that B square equals twice of A square, C square upon A square plus C square. Clear? Now, it says that if they are in HP, then what is the condition between A, B, C which they are going to follow? So, understand over here, if I just eliminate B, because B is A plus C by 2, I plug it in over here, I get A plus C by 2 whole square equals 2A square C square upon A square plus C square. So, from here what do you get is A square plus C square plus 2AC equals 8A square C square upon A square plus C square. So, this eventually gives you what? Let's see. This gives you A square plus C square whole square plus 2AC minus 8 A square C square equals 0. So, you basically land yourself to the step A plus C whole square plus 2AC multiplied by A minus C whole square equals 0. So, either this is 0 or this is 0, only then this product can be 0. So, if A minus C whole square is 0, this means A minus C is 0, which means A equals C. But if A is equal to C, you get 2B equals 2A, which means B equals A. So, eventually you will get A equals B equals C. So, this expression is 0, or this and this, both of them are going to hold simultaneously if A equals B equals C. This is one very condition in which they are going to hold. Another condition is that if this is 0, that means A plus C whole square plus 2AC is 0. Now, A plus C is twice of B, so you basically get twice of B whole square equals minus 2AC, right? Which means B square equals minus 1 by 2 AC. I can write this as minus 1 by 2 A into C, or I can write this as A into minus 1 by 2 C. B square equals minus 1 by 2 A into C means minus 1 by 2 A, B and C are in GP, and B square equals A into minus 1 by 2 C means A, B and minus 1 by 2 C are in GP. So either this holds or this holds. Even then in that situation this particular product will be 0, and hence both these facts of AP and HP are going to hold simultaneously. That means when AB and minus half C and minus half A, B, C are in GP, these are the three conditions, the three very situations where ABC will be in AP and A square, B square, C square will be in HP. Next question says what? That ABC are real numbers and ABC are in AP. Match the expression in column 1 with the properties or conditions in column 2. Let's see how do we need to tackle with this question. So ABC are already given in AP, that means you already have that twice of B equals A plus C. A square, B square, C square are also in AP, that means twice of B square equals A square plus C square. This is already given to you. Fine. Now A plus C whole square is what? A plus C whole square is 2B whole square. Right? What is 4B square? It is twice of 2B square. But 2B square is A square plus C square. So this is 2A square plus 2C square. This is A plus C whole square, which is A square plus C square plus twice of AC. Now 2A square minus A square is A square, 2C square minus C square is C square, minus 2AC gives you A minus C whole square is 0, which means A equals C. If A comes out to be equal to C, again B comes out to be equal to A, comes out to be equal to C. So you basically get A equals B equals C. So the first point gets matched to P. So corresponding to A, you basically shade P. Clear? Next you have A square, B square, C square are in GP. Okay, so A, B, C continue to be in AP. It's given that A square, B square, C square are in GP. That means B square whole square equals A square, C square, or B square can be written as plus minus AC. Now if B square equals AC, this means A, B, C are in GP. And if A, B, C come out to be in GP, A, B, C are already given in AP, that means again A equals B equals C. So A, B, C are coming out to be in GP, they are already given to be in AP, and therefore A equals B equals C. So corresponding to B also, option P is what comes out to be correct. Third we have A square, B square, C square are in HP. Let's see. A square, B square, C square are in HP, that means B square equals twice of A square, C square upon A square plus C square, right? Again, because they are given in AP, exact same argument like we did in the previous question. Here also again, B will be replaced by A plus C by 2. And this is how the expression is going to just be in terms of A and C. Fine. Now when you simplify, you get A plus C whole square plus 2AC multiplied by A minus C whole square equals 0. Again you get either A equals C, which eventually would mean A equals B equals C, or you are going to get that if this is equals to 0 means what? A plus C will be replaced by 2B. So you are basically going to get from here, if this is equal to 0 means that A or minus 1 by 2A, B and C are in GP, or A, B minus 1 by 2C are in GP, and from here you are going to get that A equals B equals C. So corresponding to option number C, P, Q, R, all three are going to be shaded. P also, Q also, and R also. Fine. Then you have D, that is A plus B plus C is 3 by 2. Then what among those are going to hold? So if A plus B plus C is 3 by 2, So you have A plus B plus C is 3 by 2. You already know A plus C is twice of B. If A plus C is twice of B plus B is 3 by 2. Thrice of B is 3 by 2, B is 1 by 2. So D is basically going to be shaded to S. Fine. Moving on to the next question we have, suppose 4 distinct positive numbers. So suppose 4 distinct positive numbers A1, A2, A3, A4 are in GP. If that is the situation, I am going to say let the first term of that GP be small a and the common ratio be small r. So you get A1 is A, A2 is AR, A3 is AR square and A4 is AR cube. B1 is A1. So B1 is A. B2 is B1 plus A2. B1 is A and A2 is AR. So A plus AR, which is A1 plus R. B3 is what? B3 is B2 plus A3. B2 plus A3. B2 is B1 plus A2. B1 is A plus A2. What is it? A. B1 is A plus A2, so we've already written that. B3 is B2 plus A3, that means A 1 plus R plus AR square, which means A common 1 plus R square, and similarly you get B4 as A common 1 plus R square plus R cube. Statement 1 says that B1, B2, B3, B4 are neither in AP nor in GP. Let's check. If I talk about AP, what is B2 minus B1? B2 minus B1 is A plus AR minus A, which is AR. What is B3 minus B2? B3 is A plus AR square minus A minus AR, so you have AR square. And these two are not equal. So yes, B1, B2, B3, B4 are not in AP. But are they not in GP also? Let's check that they are in GP or not. So if I talk about B2 by B1, B2 is A 1 plus R, B1 is A, so you are just left with 1 plus R. And B3 by B2, B3 is A 1 plus R square, and here you have A 1 plus R, so you can very clearly see that both of them are again not coming out to be equal, so they are not in GP as well. And therefore statement 1 is true that they are neither in AP nor in GP. Are they in HP? Are they in HP or not? So for HP, what do you check basically? What do you check for HP? That the reciprocals should be in AP. So B1, B2, B3, B4 are in HP or not? That means 1 by B1, 1 by B2, 1 by B3, 1 by B4 are in AP or not? So for that, 1 by B2 minus 1 by B1, if it comes out to be equal to 1 by B3 minus 1 by B2, that means yes, they are in AP, but you are going to find they are not going to come out to be equal, in which case the reciprocals are not coming out to be in AP, so the terms will not be in HP. So these terms are in HP, this is false and this is true. Statement 1 is true and statement 2 is false. Clear? Next is this particular series is given to us. Statement 1 is giving you the sum of this series, statement 2 is also given, so which is giving you the correct sum is what we need to find. So here, if you carefully observe this, it's already given to you, the general term is given to you, TR, that is the rth term is given as R square upon 2R minus 1, 2R plus 1, we need to compute the sum. So what we do is, we first of all multiply 4. Why am I doing that? Because when you multiply this, you get this. So you get 4 times TR equals 4R square minus 1 plus 1 upon 2R minus 1, 2R plus 1. So I have created this particular product above also, that is 4R square minus 1. Plus 1, why? Because now I can write this as 1 plus 1 upon 2r minus 1, 2r plus 1. And this is nothing but 4 times tr, right? So 4 times tr has come out to be equal to 1 plus 1 by 2 times 1 by 2r minus 1 minus 1 by 2r plus 1. It's very simple. 2 was coming out extra, so I have multiplied and divided by 2. Now the moment you get this, what is the next step? Next step is to actually take the summation, because you need to find the sum of this series. So you get 4 times summation tr. 4 times summation tr is going to be coming out to be what? This is 1. This is going to be summation 1 r going from 1 to n plus 1 by 2 summation 1 upon 2r minus 1 minus 1 upon 2r plus 1. This is 4 times summation tr. This is just n plus 1 by 2 times. Now you can very easily see, you will have 1 by 1 minus 1 by 3 plus 1 by 3 minus 1 by 5, isn't it? See, if you put r equals 1, you get 1 upon 2 minus 1, which is 1. If you put r equals 1 over here, you get 3. So you get 1 upon 1 minus 1 upon 3 plus 1 upon 3 minus 1 upon 5 plus 1 upon 5 minus 1 upon 7, and so on. You're going to get minus 1 upon 2n plus 1. So everything is going to get cancelled. You will just be left with 1 minus 1 upon 2n plus 1. Clear? So from here, what do you have is n plus, this is 2n plus 1 minus 1, it is 2n upon 2n plus 1 or n upon 2n plus 1, because 2 gets cancelled. So you have n into 2n plus 1 plus n whole upon 2n plus 1. So n comes out common. You are left with 2n plus 1 plus 1, that is 2n plus 2. So 2 comes out common, you have n plus 1 upon 2n plus 1. And therefore this is 4 times of summation tr. So summation tr will be this thing whole upon 4, which is nn plus 1 whole upon twice of 2n plus 1. nn plus 1 whole upon twice of 2n plus 1. Yes, this is true. So statement 1 is true. What about statement 2? It is 1 upon 2n minus 1, 2n plus 1. So general term will be equal to what? It will be just r upon, what will it be? It will be r upon 2r minus 1, 2r plus 1. Not even r, it will just be equal to 1, because that's what it is. Fine. You can very easily write it as 1 by 2, 1 by 2r minus 1 minus 1 by 2r plus 1. When you take the summation, sum comes out to be equal to what? This. This means 1 by 2 comes out common. We just now saw this comes out to be 1 minus 1 by 2n plus 1. So this is 2n plus 1 minus 1. That is 2n upon 2n plus 1, 2 gets cancelled, n upon 2n plus 1, but over here it is given 1 upon 2n plus 1. So statement 1 is true, statement 2 is false. Fine. Next, what is it that you have? You have given a sequence. If it's possible to find a function f of r such that this holds, then this holds, now you need to answer some of the particular questions. What are the questions? Let's see. Questions are, what is the sum of this series? Again, it is summation 1 upon 4r square minus 1, r going from 1 to infinity. Now, this is an infinite series. So, this comes out to be very simple. This is 2r minus 1, 2r plus 1, r going from 1 to infinity. Or what I can do is r going from 1 to n and limit n tends to infinity. It's one and the same thing, right? So this comes out to be equal to what? 1 by 2. Summation 1 by 2r minus 1 minus 1 by 2r plus 1, and this is summation, or let me just write it as limit n tends to infinity. Summation has already been kept. Fine. So this comes out to be 1 minus 1 by 2n plus 1 into 1 by 2, and this is limit n tends to infinity. This is again 2n plus 1 minus 1, which is 2n upon 2n plus 1, but 2 gets cancelled, you're left with n upon 2n plus 1. N tends to infinity, or rather than that, just here also if you apply n tends to infinity, you get 1 upon infinity is 0. So you get 1 by 2 minus 0, which is 0. So which is 1 by 2. So your answer is 1 by 2 minus 0, which is 1 by 2. Okay. Next, what is it that you have? You have, if u1 is 1 and un plus 1 is 2un plus 1, then un plus 1 is equal to what? So if un plus 1 minus un, if I consider, un plus 1 is 2un plus 1 minus, so un will be what? Un will be, when you replace n by n minus 1. When you replace n by n minus 1, you actually get un. So this will be 2un minus 1 plus 1. So this is twice of un minus 1. Right? Now next what? This is again twice of, what is this? So un plus 1 minus un is un minus 1. Un minus minus 1 will be twice of, again, so this is 2 square, un minus 1 minus un minus 2. And this is going to go on. You will be left with 2 to the power n minus 1, u2 minus u1. u1 is 1, and what is u2? u2 will be 2 times u1 plus 1, that is 2 into 1 plus 1, that is 3. So this is 3 minus 1. So this is 2 to the power n minus 1 into 2, which is 2 to the power n. This is not un plus 1, this is un plus 1 minus un. So un plus 1 is coming out to be 2 to the power n minus un. Right? This will be 2 to the power n, this un plus 1 is 2 to the power n minus un. So un will be 2 to the power n minus 1 minus un minus 1. Right? Then un minus 1 will be 2 to the power n minus 2 minus un minus 2. This is this, so un will be 2 to the power n minus 1 minus un, so this will be minus this plus this. And the moment you write this, what are you left with is, now un minus 1 will be what? This is un plus 1. Un plus 1 is 2 to the power n minus un. Fine. So un is 2 to the power n minus 1 minus un minus 1. Right? So this will be plus. Similarly, when you are going to carry this forward, again, carry this forward. Why? Because this will be un minus 1. Un minus 1 is 2 to the power n minus 2. This is plus 2 to the power n minus 2 minus un minus 2. When you carry this forward, this argument, you basically get 2 to the power n plus 1 minus 1 as your answer. Fine, and therefore un plus 1 actually comes out to be equal to 2 to the power n plus 1 minus 1. Carrying this forward, same argument, carrying it forward and forward and forward, you get this. After that you have sum of this series is what? Let's see what is the sum of this series. So you are given TR is 1 upon R into R plus 1, R plus 2. That means RTR is equal to 1 upon R plus 1 into R plus 2. RTR is this. Very conveniently, I can say this is same as R plus 3 times TR plus 1. You can check. TR plus 1 will be what? TR plus 1 will be R plus 1, R plus 2, R plus 3. I just have R plus 1, R plus 2. So I multiply by R plus 3 so that R plus 3 can get cancelled. So you have this, which you can write as R plus 2 plus 1. So that is R plus 2 times tr plus 1 or r plus 1 times tr plus 1 plus twice of tr plus 1. So this gives you rtr, or other than that let me write it as 2 times tr plus 1 equals rtr minus r plus 1 tr plus 1. So when you need to find the summation, this is r going from 1 to n minus 1 because till tn you need to find. This is what? 1t1 minus 2t2 plus 2t2 minus 3t3 plus 3t3 minus 4t4. So you are getting to get the terms all cancelled. You just have 1t1 minus what is n plus 1 tn plus 1. Tn plus 1 will be 1 upon n plus 1, n plus 2, n plus 3, right? So what will be n plus 1 tn plus 1, it will be n plus 1 into 1 upon n plus 1, n plus 2, n plus 3. N plus 1 gets cancelled, you just have minus 1 upon n plus 2, n plus 3. Clear? So next is, let's look at the argument now. What is T1? You are going to replace this by summation TR plus 1, R going from 1 to n comes out to be equal to 1 by 2 minus, now see I am replacing this n by infinity. So you basically get 1 upon infinity is 0, you are just left with 1 by 2 and this 2 from here makes it actually 1 by 4, and that is what is the sum, that is 1 by 4 because you are tending everything to infinity. So this term gets just vanished. Fine. Next what you have is sum of this series is what? Let's see. Here TR is different, the rth term, general term is very much different. What is the rth term? It is r into r plus 1, r plus 2, right? Now r plus 3 times tr equals r times tr plus 1. R times tr plus 1 will be what? R times tr plus 1 will be r plus 1, r plus 2, r plus 3. R plus 1, r plus 2, r plus 3. R plus 3 is extra, so that is why, that's what I am writing over here. R plus 3 times tr equals r times tr plus 1. And therefore, this can be written as rtr plus 3tr, which is 4tr minus rtr equals rtr plus 1. So this becomes what? 4tr equals rtr plus 1 minus, what is this? This is rtr plus 4tr minus rtr. So here what you are going to get is this gets cancelled. This gets cancelled, so you are left with rtr plus 1. That is it. Fine. The moment you get this, how basically you extend your argument to get the sum of this series is what you need to think now. So now, once we have defined the general term also and established the relation between consecutive terms of this series, we now need to get to the sum of this particular series. So think upon it and then we are going to get back to the question and the one after this also. Okay. So over here, as we were trying to basically resolve this issue, we had tr equals r plus 1, r plus 2. So r plus 3 tr is r times tr plus 1. So rtr plus 3tr. 3tr can be written as 4tr minus tr. 4tr minus tr. The moment you get this, what you have is 4tr plus r minus 1 tr equals rtr plus 1. So you eventually get 4tr equals rtr plus 1 minus r minus 1 tr. And therefore, when you take the summation, the moment you take the summation, the infinite summation actually comes out to be 4 factorial n plus 3c4. That's what you get it. What you get? 4 factorial n plus 3c4, very easily you're going to get this particular thing as your answer. Fine, that's how you get the sum of this particular series. So here also in the previous question, what did we see? In here, when we had established that un plus 1 minus un was 2 to the power n, right? In that case, next step was to say that un plus 1 is 2 to the power n plus un. Fine. So you keep on extending the things, This becomes 2 to the power n minus 1 plus un minus 1 and so on, and that is what gives you 2 to the power n plus 1 minus 1. So just if you have done the very establishment of result for one particular variable, it just keeps on consecutively getting the same thing gets forwarded. Same thing gets forwarded when you replace n by n minus 1, n by n minus 2, n by n minus 3 and so on. Clear? So we are through with the sum of the series also. Let's look at the next question. What is the next question? If xn is 1 square plus 2 into 2 square plus 3 square plus 2 into 4 square and so on, and that is also given to you like this, n plus 1 whole square whole upon 2. If n is even, then calculate this. What is this? So if you can very nicely see, x51 can be written as x50 plus 51 square, right? What is x50? It is given to you, 50 is even, it is given to you as 50 into 51 square whole upon 2 plus 51 square. So this gives you 25 into 51 square plus 51 square. So 51 square comes out common. This is 51 square multiplied by 26, right? That is what happens to be the scenario. So this is x51, and this is 26. 26 is what? 13 into 2. 13 into 2 is 26. So x51 upon 51 square into 13 comes out to be what? x51 upon 51 square into 13 comes out to be equal to 2. So x51 upon 51 square into 13 is the integer 2. Clear? So revise all the questions very nicely, practice them thoroughly, they are very important. That's it from my side. Thank you.